Oh, I forgot.
All right. Kiamo, Declan, Jaden, Andy, Anthony, hang on a minute. Lucy, Josh,
She was I didn't oh my god, when did this come out? I don't know any of those movies. But I listened to music and I looks like Killing Sessions. It's from the 80s. Or 1989. Look, I was like, how is this?
all right.
Oh yeah. Why does it Why does it I do that. It was like I got out. That's why I did my friend Jill put it in one. I've done it when
Okay, for the Pear Deck, ladies and gentlemen, you're going to need that reference sheet that has the precipitates on it. So let's take that out, ladies and gentlemen. All right, today we're going to start getting you ready for your final exam. You have some work that you need to get done before you come in on Monday. Otherwise, I don't guarantee that when you come in on Monday, you will have enough time to finish the final exam. So today and tomorrow, you're going to start doing some of the pre-work that you need to be done. I'm going to show you what the exam is going to be like, what the activity that you're going to be doing is, and I'm going to be giving you some references. Rose, I need that for now. Okay? So, that is the plan for today and tomorrow, ladies and gentlemen. Questions? All right, then here's the first question for you, ladies and gentlemen. Let me unfreeze this. There we go. All right. So, will the following compound be aqueous or a solid and precipitate? So, find that on the back of your not on your periodic table, of your reference sheet, ladies and gentlemen. Take your thumb sign, put it on whichever one you think it is. Will it be aqueous or will it be a solid, ladies and gentlemen? All right. Michaela's. What do you got? Between the two of you, what do you got? Is it the same answer or did you argue over it? Okay, so tell me, which one is it?
What are we doing?
Well, what'd you have, Michaela? You have aqueous?
What are we asking?
It will be aqueous. When you look at your periodic table, ladies and gentlemen, chlorine is in the second group, the second table down, the second one. It will dissolve, be aqueous with most cations. The exceptions are silver, lead, and mercury. Since it is not with one of those exceptions, it will be aqueous. Joshua, did you have a question?
So the difference between this one and this one is that we react
we are using the side that has the 3 like tables on it for double replacement reactions. The other side is for single replacement reactions. Here's what I will tell you. This is what you need for the lab. This side right here. This side right here. Okay? Calcium chromate. Will it be a precipitate, a solid, or will it stay aqueous? Calcium chromate. So again, we find it based on the CrO4. That's what we're looking up on our table. So find CrO4. See which section it is. Those at the top, the very top section, ladies and gentlemen, are always aqueous. There is nothing you can put them with where they will not be aqueous. Then, ladies and gentlemen, there is the middle section, where they are normally aqueous, but there are some exceptions that will make them precipitate on the far right-hand side. And in the bottom table, ladies and gentlemen, those things are normally a precipitate. However, there are some exceptions in the middle where they will be aqueous, including a double exception in there. So, KP, when we are all said and done, which is this? This will be a solid, ladies and gentlemen. Chromate is in the bottom of that middle section, the very last one. And it will normally be aqueous unless it happens to be with lead, silver, barium, strontium, or calcium. It's with calcium, so it will precipitate. Good. Questions? Wonderful. Okay. Ammonium carbonate. Ammonium carbonate, aqueous or a precipitate?
Oh, sure.
Dante, which one?
Aqueous.
This one is aqueous, ladies and gentlemen. Carbonate is down in the bottom section, the second one from the very bottom of this table. Carbonate is normally a precipitate unless it is with ammonium or the cations of column 1, except for lithium. Well, here it's with ammonium, so therefore, ladies and gentlemen, it will be aqueous. It is an exception to the section where it would normally precipitate. Questions? All right, how about lead chloride? Lead chloride. Is that going to be aqueous or is that going to make a solid precipitate? Keanu, what do we think?
It'll be a solid.
Okay, it will be a solid. It is in the second table down. It is the second one is chlorine. It will normally be aqueous, but there are 3 exceptions that will make it a solid. Silver, lead, and mercury. And since it's with lead here, that's what makes it a solid. Questions, ladies and gentlemen? Lithium sulfide. Lithium sulfide. Will this be aqueous or will this be a solid, ladies and gentlemen? Lithium sulfide. Lucy, what do you think? Lithium sulfide, aqueous or a solid? Aqueous. You are correct. Now, sulfur is down in the bottom table, ladies and gentlemen. Sulfur will normally precipitate with most cations. The exceptions are ammoniums and the cations of columns 1 and 2. Lithium is in column 1, ladies and gentlemen. So it is an exception that will make it be aqueous. Questions? All right, how about lithium phosphate? Lithium phosphate. Find phosphate, find lithium, or see if it's one of the things that it will be an exception, or if it's one of the things that it's normally with. All right, Evan, what you got? It is a solid. Okay? Now, if you look, it is the very... Yes, Declan.
Oh, I'm sorry. Continue, then I'll ask.
Okay? If you look, it is at the very bottom of this table. Those things are normally precipitates. They're normally solids. There are some exceptions. The cations of group 1. Lithium is in the cations in group 1. But it says the cations of group 1 except for lithium. So because of that, even though most of the cations are an exception and would be aqueous, lithium is not one of those. So therefore it does, or it is a solid, ladies and gentlemen. Questions? Go ahead, Declan.
What's lithium's like special ability to not be a part of?
Don't know. It's just its chemical properties. It's just the chemical properties. So, again, great question, but you're asking me to explain things that, again, we may not totally understand. Okay? Maybe there's some guy out there who could explain it to you. I don't know for sure. Okay? I don't know for sure. Questions, ladies and gentlemen? All right, close your computers. Put them away. Leave out your periodic tables on your desk. Okay? Leave out your solubility charts on your desk. Okay? So, okay. In a few minutes, ladies and gentlemen, I will give you this sheet. So here's what your final exam is, ladies and gentlemen. There will be 6 stations set up in the back of the room. Those 6 stations will contain a number of bottles like you see on the front desk up here. Inside those bottles is a solution, an aqueous solution. Now, the 4 solutions in that set, my setup here is different, but in the first set, one of them will be sodium chloride, one of them will be potassium chromate, one of them will be silver nitrate, one of them will be sodium nitrate. We know what the 4 solutions are. Your job is to figure out which one is in bottle A, which one is in bottle B, which one is in bottle C, and which one is in bottle D. Okay? Now, some of them you will literally be able to go up to and identify right away. If you look at the 4 bottles that are in front of you right now, what is unique about some of the bottles? One has a yellowish tint to it. There is something that means. We will explain in a minute. What else?
One's in a tinted bottle.
That's not a tinted bottle. That bottle started out just like the other ones. But one is a very different color than the other 2, isn't it? So if I know what this color means, I can identify this. If I know what this color means, I can identify it. Can I identify these by looking at them? No. So, what? So how am I supposed to identify it based on the amount of liquid? It's a good thought. Okay, there's less in one than the other, but it still doesn't help me to know which one is which. Okay? Now, as I said, you will be able to walk up to a station and possibly identify things right away. If you can, what you are going to do is you're going to fill out this chart. So in A, what solution was in A? What one was in B? What one was in C? What one was in D? Maybe I know that one is this solution because of its color. I'll fill that out first. Right away, I'll be done with it. Okay? Now, when you do this, ladies and gentlemen, on your test, you are going to write formulas, not names here. And if your name is or if your formula is correct, but you don't do a correct formula, so let me rephrase that. Yeah, I know that didn't come out the way I want. If your identification is correct, if you're saying this is sodium chloride and you put it in the right spot, that's good. If your formula is correct, you do NaCl, not NaCl2, not Na2Cl. That's good. You get the full credit for it. However, if you miss either one, you lose a half a point. Okay? For every 3 that you get wrong, ladies and gentlemen, your grade will be reduced 1 letter grade. Your grade will be reduced 1 letter grade. Now, here's the thing. I've given you all of these names, right? You can find the formulas anytime you want and write them next to it. No way you should get it wrong. You can use all of your notes. You can go online and look it up. I don't care. But you need to find the formulas for all of these things. By the way, hey, here's silver nitrate. Here's silver nitrate. Okay, here's silver nitrate. Formula isn't going to change every time you use it in here. Okay? Sodium chloride. Sodium chloride. Sodium chloride. Sodium chloride. Okay? You're going to be using the same compounds over and over again. Okay? Now again, we can identify 2 of those based on colors. The other 2 are clear. We can't identify them based on colors. So we're going to have to identify them based on what they react with and what they don't react with. We're going to show you how to do that today. So part of this lab is some pre-work that you're going to get done today and tomorrow. Okay? But I'm going to show you how to do that today. Okay? Each of these sets, ladies and gentlemen, has a certain number of precipitates. In other words, I will tell you how many precipitates, how many reactions you should get in this set. And it's a different number for each set. Okay? And then we will check and see how many you get when you make your predictions. You are going to have to write 4 fully balanced chemical equations. This plus this produces this plus this. Balanced with correct coefficients in front and the correct symbols down below. Now, the only 2 symbols you're going to use in this lab are AQ and solid. And I'm telling you right now, everything on the reactant side is aqueous because they're in solutions. Okay? And if a reaction doesn't happen, I don't want you writing a reaction for it. So you got to find one where you're going to create a precipitate. You're going to know that long before you need to write this reaction. Okay? Matter of fact, you can do these 4 before you ever walk into the room on Monday morning. You can have these done. Okay? Now, what it looks like is for every one of them, there is a table like this. This is the table that you need to finish before you come in to do the lab. This table says, okay, what happens when I mix sodium chloride and potassium chromate together? What do I get, and is there an actual reaction there? What do I get when I mix sodium chloride and silver nitrate? What do I get when I mix sodium chloride and sodium nitrate? What are my reactions going to be? Am I going to find a precipitate? Now, in these 3, 4, 5, 6 boxes, you will find a certain number of precipitates. I'll tell you how many you should find. You've got to find them. I'll show you how to do that in a minute. This is done before you come in. This is done before you come into class. Then when you come into class, ladies and gentlemen, there will be a chart like this at your station. And there will be one of these what are called a well plate at your station. And you lay this on top of this part. And you take bottle A and you put a drop in this spot, and this spot. Then you take bottle B and you put a drop here, here, and here. You take C and you put it here, here, and here. You take D and you put it here, here, and here. This will mix A and B. And we'll see if we get a reaction. This spot will mix A and C. See if we get a reaction. This spot will mix A and D. We'll see if we get a reaction. You predicted a certain number of precipitates up here. We should find them here. Now, you should be able to figure out what reacted based on which bottles we get a precipitate in. Now it's a matter of figuring out what was in those bottles. We'll show you how to do that. Okay? We're going to get to this. Okay? I will give you this sheet before too long today. Okay? Now, I will also give you some help. Okay? Here's what I mean, ladies and gentlemen. You do not need to write this down now. But in set 1, you will find 2 precipitates. In set 2, you will find 3 precipitates. Of all the reactions that happen, 3 of them will form precipitates. So 3 of them will be a reaction. In set 3, you will find 6 precipitates. In set 4, 5, and 6, you will find 2 each. 2 each. For a total of 17 precipitates. Those 4 balanced chemical reactions that I asked you to write, you can take from any set you want and write the balanced equation of one of the reactions that created a precipitate in it. The only thing you cannot do is if the same reaction happens in a later set, the same 2 chemicals are mixed, you cannot give me the same exact reaction over again, the same exact balanced equation. You have to find 4 different ones that you are going to give me. I know, a lot of questions. Don't panic. Now, here's the part that becomes very helpful. If you have chromate ion in a solution, it will make a yellow color in the solution. If you have copper in the solution, if it's copper something, that will be a blue color solution. If you have cobalt, it will be pink. If you have iron, it will be an orangish brown color. If you have silver nitrate in the bottle, again, you do not need to write these down. I will, when I give you your sheet that you're going to do the lab on, that would be a better place to put these notes, and I will put it back up there for you. Okay? If you have silver nitrate in there, that will mean it will have gray and silver deposits. And finally, ladies and gentlemen, if there is acetate in your bottle, it will smell like vinegar. Okay? These are some ways that we can look at a bottle and tell what's in it. So of my 4 bottles up here, what do we know about one of them? Why?
Because it's yellow.
Good. There's chromate in one of them because it's yellow.
There's iron.
Nope, not iron. Nope, that's not orange brown. I'm sorry. That's silver nitrate in that bottle. That's what happens to a silver nitrate bottle. By the way, ladies and gentlemen, silver nitrate used to be used for something we no longer do in reality anymore. It used to be used to develop film. So exposure to light causes it to turn that grayish silver color. Okay? By the way, you get silver nitrate on your hands, on your clothing, it will stain them. Okay? So if you're wearing a nice white t-shirt on Monday and you get silver nitrate on it, which you shouldn't because all you're doing is dispensing 1 drop of it at a time, it will stain your clothes, it will stain your fingers, it will stain whatever you come in contact with it with. Okay? Now, I will have this sheet out for you as well, ladies and gentlemen. Okay, there are some clues that we can get from a precipitate. If we make silver chromate, it will turn a blood red color. So when you mix the 2 together, it will turn blood red when you create silver chromate. If you were to create silver chloride, it will create a milky white precipitate. If you have an iodide precipitate, it will be a bright yellow color. And if you make cobalt 2 hydroxide, it will have a bright blue color. So these can help you when you need to identify what precipitate was formed. Okay? Now, I don't give you what all of the precipitate looks like, but those may be handy for you. Okay? All right. So here we go, ladies and gentlemen. This is my set that I have up here right now. These are the 4 chemicals that I have. So we're going to walk through and we're going to show you what you're going to do when I give you your yellow sheets in a moment, ladies and gentlemen. All right. So here's where I need your help, ladies and gentlemen. Silver nitrate, what is the formula for it? Let's get it correct. AgNO3. Okay? Now, what does barium nitrate look like? If you want to get ahead, somebody start doing potassium chromate, somebody start doing sodium chloride, so that way you can look like, okay, I got this right away, Mr. Brand, in a minute. So what's barium nitrate? Close.
Oh, yeah.
2. Sodium chloride. NaCl. And finally, potassium chromate. K2CrO4. Okay, now on the side, these are also going to be the same because they're not changing, obviously. Potassium chromate, K2CrO4. Okay, so the reason this box is X'd off is because if you mix silver nitrate and silver nitrate, what are you going to get?
More silver nitrate.
Yeah. The reason this box is X'd off is it is identical to this box right here. It would be the same thing. So that is why half of this table is gone, because in this half over here, we're going to see the same reaction here that we would have here. So why do it twice? Does that make sense? Okay, good. So you're telling me we did something right here. Excellent. Wonderful. Awesome. Let me get rid of some of these marks. Okay. All right. So now let's start with this box right here, ladies and gentlemen. This box right here, you are going to mix barium nitrate and silver nitrate. Guess what will happen if you mix barium nitrate and silver nitrate? No, nothing. Because you've got nitrate in both of these. So there cannot possibly be a reaction here because you have the same anion. If you are replacing barium and silver, if they're switching places, they're still going to be with nitrate because that's what your anion is. So there cannot possibly be a reaction. So if you have the same anion, the same negative part, there can't be a reaction. If you have the same positive part, there can't be a reaction. Because even if copper switched with copper, it would be aqueous because it was aqueous to start with. Does that make sense? So there's no way this can have a reaction. Now we go to the next one though. For the next one, if we mix silver nitrate and sodium chloride, the sodium and the silver could switch spots, and we could get sodium nitrate, NaNO3. We could also get AgCl. Now, silver is a +1, chlorine is a -1, so this compound is fine. Sodium is a +1, nitrate is a -1, this compound is fine. Now, look on the back or look on your reference sheet. Will either one of these two things precipitate, Joshua? This precipitates. This one cannot then. That's one of the 3 precipitates we are looking for. So when I mix silver nitrate and sodium chloride together, I'm expecting to get a reaction. Okay? I'm expecting to get a reaction. Now let's go with silver nitrate and potassium chromate. If I mix those two together, the two products that I could get would be KNO3. K is a +1, NO3 is a -1. Or I could get Ag2CrO4. Silver is a +1, chromate is a -2. That's why I get that formula. Now, someone please check these two and tell me if either one of them will precipitate. This is a precipitate down here, ladies and gentlemen. So I'm crossing off that one, and I'm leaving this. I get a reaction when I mix these two together. That's 2 of the 3. Okay? Now I do sodium chloride and barium nitrate. So now I'm going to end up with sodium nitrate, NaNO3, and barium chloride, BaCl2. Why? Barium is a +2, chlorine is a -1, still writing good compounds. Can someone tell me if either one of these will precipitate? All right, then I cross both of them off, and what that means is there's going to be no reaction. I don't need to put NR, I'm just leaving it blank, okay? Now, again, when you find a precipitate, circle it, highlight it, do something so that you know, okay, these are the ones that I'm looking for. Okay? So now we go to our next box here. Barium nitrate and potassium chromate. So that means I'm going to make potassium nitrate, or I am going to make barium chromate. Okay? Now, we already know that potassium nitrate did not precipitate here, correct? So what does that mean? It won't precipitate there. If it didn't one time with potassium, it's not going to another. How about barium chromate? So this is our third and final precipitate. What that means, ladies and gentlemen, is we'll check this, but we would get NaCrO4, Na2CrO4, and we would get KCl. KCl, will it precipitate? No. What about Na2CrO4? All right, so I have my precipitates. Okay? I have my precipitates. Okay? Questions? Okay. All right. I did that so I don't lose this, ladies and gentlemen. Otherwise, when I switch my screens, it's going to go away. Okay. So this is what the part that you're going to be able to do today and tomorrow before you ever walk into the lab. You're going to be able to find all of the things that will precipitate. Questions? Okay. Now, when it comes time to do the lab, okay? Now, again, these were the 4 things that I had. Here are my bottles. 1, 2, 3, and 4. Tell me something I know right away. Don't waste my time here. Tell me something I can identify right away. No, think back to what we did a minute ago. That I told you not to write it down. Okay? I told you not to write it down. Yellow has chromate. Thank you, KP. Yellow has chromate in it, right? Okay? So yellow has chromate in it. Okay? So, of these 4 bottles, which one has chromate in it? 3. So what does it have to be? Which it has that bottle 3 has to be potassium chromate. You've identified your first one. We know that that bottle has to be potassium chromate. Okay? We know that that bottle has to be potassium chromate. Okay? So, all right. So, bottle 3, K2CrO4. Boom, you write that down, you've got your first point. Write the formula correctly, you got the whole point. Okay, which other one can we identify? Silver nitrate. Which bottle is it? Okay, So silver, whoops, sorry, I'm doing that wrong. My bad, my bad, my bad. What should the formula be? Let's try this again. I know. You got to double click it, and I hate that. K2CrO4 AgNO3. So really, I need to figure out which one is barium nitrate and which one is sodium chloride. Okay? Now I'm going to do the other part of my lab, ladies and gentlemen, which is this. Whoops. Okay, there is one that smells like vinegar. Does it even pay to smell these? No, why? There's no acetate in there. Acetate isn't one of the parts of any of these solutions. Now, here's what I'm going to tell you. You're going to get to a station where there is acetate. And you're going to call me over and you go, Mr. Brown, I can't figure this out. And I'm going to go, did you sniff any of them? Well, no, why would I do that? Because there's acetate in one. Okay? You can smell all of them. Go for it. There's only one that's going to stink. And that's the acetate one. Okay. So now, here's what I'm going to do, ladies and gentlemen. Now I'm going to actually mix my things together. In the end, we should find 3 precipitates. Now, I set this up to help you, ladies and gentlemen. Go ahead, Joshua.
So, wouldn't one of them be a precipitate too, since we already found the testing? So the last precipitate would be one of the remaining bottles.
Hold on, you're getting ahead of me. Okay? You're right. We could use that to help identify things, but that's what I'm going to show you in a minute, so just hang on. So now, I'm going to take bottle 1. And bottle 1 goes everywhere where there is green. Now, I'm not going to put it up here. Why? Because I'd be mixing it with bottle 1 and nothing's going to happen. So I'm going to put it here, sorry, and down there. Okay? Why?
Yeah, it's the glare, like the green.
Okay, because I'm like, it was. I'm looking at it here, and I'm like, the green is there, but you guys aren't seeing it. I'm sorry about that. Okay, all right. So now we take bottle 1. Now, a couple of things when you use these bottles. Number 1, you take one cap off at a time and you put it back on the same bottle, because if you mix caps, you might contaminate the bottle. Okay. Number 2, you're just dispensing 1 drop at a time. These are dropper bottles. You turn them upside down, you press them, and they will dispense 1 drop at a time. You only need 1 to 2 drops. That is it. Okay? And number 3, don't take the tip of one bottle and press it into the other solution when you are putting the 2 together. It's a dropper bottle. Let it drop. Okay? So I'm going to put a drop here, here, and here. And again, 1 to 2 drops is all you need. Now I'm going to take bottle 2. Bottle 2 goes here, here, and here. The orange goes here, you go to the X, and then you go down and do the other 2. Okay?
So you just follow the highlight.
That's why I got it set up for you. There, there, and there. Now, when I mix these 2 together, did anything happen? No. And again, with the highlighter, you may have to slide things over eventually. Okay? This is the first time I've done it this way with the highlighter to make it easier for you to tell where things goes, but it may interfere with being able to see something. So when I'm all done, I'll slide this over onto either a black background or a white background just to see what's going on. Bottle 3. Bottle 3 goes here, here, and here. And I know what's in bottle 3, and we may be able to use that in a second. Okay? Okay. Now, what you guys are having a hard time seeing, there's definitely something going on here. Okay? And I will show you in a minute by pulling it off of the thing. But it is like a creamy yellow color. Creamy. Okay? So that means that a what has happened? A reaction, a precipitate has happened. Okay, now we're going to finish up with the silver nitrate, and it goes in these three spots along the bottom.
Whoa.
All right. How many reactions were we expecting? Well, is that one?
For sure.
Yeah. How about there?
Yeah, looks like it.
Okay, so then we've got our three. Let me slide this.
Oh,
That's kind of cool. Okay. Oh, it's
One.
red.
2, 3. There's our three reactions, ladies and gentlemen, just like we predicted would happen. Okay? Now we need to use this to figure out what's in what bottle. Okay?
oh, you said something about blood red.
Okay, I did. But let's go back to this, our predictions. What two things are we still looking for? Which ones have we not figured out yet? Sodium chloride and barium nitrate. So I do know this about sodium chloride. Sodium chloride does make a precipitate with what? Silver nitrate. Okay? But we do have another one that we're looking at. What is the other one that we haven't identified yet? The barium nitrate. Barium nitrate doesn't react here. Okay? Doesn't react here, but it does react here, right? What does the barium nitrate react with?
Potassium chloride.
Do we know which one is the potassium chromate? So we know that number 3 is potassium chromate, and we know that it should react with either 1 or 2. Correct? Okay, how do you remember 2 though?
What do you mean?
Well, these are not in the same order as the 1, 2, 3, 4 necessarily.
Oh, never mind.
So that again, that's just a point I wanted to make. Okay? If it was, my God, this would be the easiest lab in the world. Well, Mr. Brand, number 1 is silver nitrate. Number 2, well, we already know number 4 is silver nitrate. Okay? So again, I know what you're thinking. Well, okay, should be in this spot. It isn't going to necessarily be in that spot. Okay? Isn't necessary. Because if you remember, where were our 3 precipitates? They were here, here, and here, right? So these are not in the same place as they are as our predictions, just so you understand. Okay? So we should be able to identify barium nitrate as the one that reacts with potassium chromate, correct? Yes or no?
Yeah.
Okay. Now we got to be careful. What I mean by that is, it is possible that silver nitrate could have reacted with both of these things, right? Okay? And it does react with both the potassium and it reacts with the sodium. Well, we weren't debating on potassium. We knew what it was. So sometimes both clear solutions, maybe they will react with the same thing. That doesn't help us identify it. Okay? So we've got to look at different things here. We can't identify sodium chloride by the number of reactions it has, because how many reactions will it have? No, we'll only have 1. Sodium chloride will only react. I got all kinds of colors up here. I'm sorry for that. But it only reacts with 1 thing. How many things does barium nitrate react with? 1 thing. So we can't use that as a way of judging it. Sometimes by how many things it will react with, we can figure out what something is. Do you understand what I mean by that? Maybe it'll react with 2 things. Like if we were trying to figure out which one was potassium chromate was, it does react with 2 things, right? So we could have identified it that way as well. Okay? Joshua, you have a question? Or?
I think I've figured out what 1 and 2 is.
Okay, well, let's see. Let's put this back. Okay? Let's go back to that. So what we're looking for is which one reacted with number 3, correct? That will tell us that it is barium nitrate. Which one reacted with number 3? All right, so here's number 3. Wow. This one reacted with number 3, and this one reacted with number 3. But we were expecting 2 to react with number 3, correct? Which one is this? 3 and what?
4.
We already know what 3 and 4 both are, correct? So what is this one? Which one is it?
1 and 3.
1 and 3. So number 1 is our barium nitrate. Number 1 is our barium nitrate, ladies and gentlemen. Okay? So number 1, that was definitely not the tool that I wanted to use. Barium nitrate. So what does that mean for 2?
Sodium chloride.
It has to be sodium chloride. But also, sodium chloride was supposed to react with what?
Silver.
Silver nitrate. So we should see a reaction between 2 and what? 2 and 4. Let's double check to make sure we got a reaction between 2 and 4. Here's 2, here's 4. Do we got a reaction there? You've identified it. You've identified it. That is what you're going to be doing in your lab activity. It is, but most of the stuff you will have done ahead of time. Okay? Most of the stuff you will have done ahead of time. All right? Questions? All right. When you're done, ladies and gentlemen, you take this whole tray over to a sink, run lots of water, send everything down the drain, dry it off, move to your next station. Okay? Now let's think about this. An hour and a half. Okay? How long does that give you at a station?
6 stations.
6 stations. 15 minutes, basically. 15 minutes. Now, that is assuming that you have your work done ahead of time. Okay? That is assuming that you have your work done ahead of time. Tomorrow, we will do one with a little bigger set, a 5x5 set. Yes, Josh.
We're going to be able to use these papers on the lab. Or no?
As far as I'm concerned, you can use your papers, you can use your notes. I will have stuff sitting out there for you that will be helpful. And you can work with a partner. No groups of 3, but you can work in groups of 2 if you want. If you're going to fight all the time, don't work with that person.
We never fight. What are you saying?
I will only have 12 stations set up. If you're choosing to work alone, you may be waiting. Because 12 stations can accommodate 24 people. Now, first thing, please put your name on the top of this paper.
That's 1 point. So let's write all of the.
So, here is my suggestion to you, ladies and gentlemen. This is where I would begin. You are going to have to do the predictions part. I would start by doing this, ladies and gentlemen. I would start by writing the formulas for each of the compounds. So, this is the one set I will help you with. Sodium chloride, what is the formula? NaCl. Put it there. Put it there. Potassium chromate, what is the formula? Silver nitrate. Somebody. Sodium nitrate. Are all of those correct? Yes, no, maybe so. Okay. So again, in this box right here, ladies and gentlemen, you are going to write the products that you would get between a double replacement reaction between sodium chloride and potassium chromate. You should get 2 compounds. Now, before we go any further, where can I put Na? All right, where can I put Nr, no reaction? The 2 nitrates. So, silver nitrate and sodium nitrate, correct? Nr. Where else? The 2 what? Where the 2 sodiums are. You don't even have to do anything there. We know nothing can happen there. Now, of these 4, ladies and gentlemen, of these 4, there are 2 precipitates in set 1. My suggestion, under set 1 predictions, put 2 PPT or just 2S, however you want to remember it. 2 precipitates or 2 solids. That's how many you should find there. Okay? That's how many you should find there. For set 2, go to the next page. For set 2, you will find 3. For set 3, you will find 6. And then for set 4, 5, and 6, you will find 2 each. If you find more than that, you've got a problem. If you find less than that, you've got a problem. If you have questions, raise your hand. I will come over and I will give you as much help as I can without giving you answers. Does anyone still need to see this? No? Then here's what I'm going to do for you as well. If I were you, if you have a set that has chromate in it, I would put a note that you are expecting to find a yellow bottle in that set. If you have a set that has copper, you are expecting to find a bottle with a blue solution in it. You do not necessarily need to copy these down. You can if you want. I will have these out there. But as you go through and you look at the names in the sets, so when you go through, maybe on the first page, set 1, where it has sodium chloride. Okay, I got no way of identifying that. Potassium chromate. Maybe I put a note next to that, yellow. Silver nitrate, that gray bottle. Sodium nitrate, I got no note for that. Okay? Section 2 has iron in it. Okay? Iron is going to be an orange-brown color. Shouldn't see orange-brown in set 1. We'll see it in set 2. In set 3, will you see anything? And actually, if I were you right now, ladies and gentlemen, I would find the acetate and I would put a note next to it that says vinegar. Smell. That's the one set you can go sniffing around. Normally, people sniff around the first 3 sets, don't find anything, and then they're like, oh, there's no acetate in here. This sheet, ladies and gentlemen, will be out at every lab station on Monday. Okay? Again, if you wrote it down, great. But just so you know, we'll be out at every lab station on Monday as well. Yes. Always. Correct. So again, here's the other thing. Reading up next. These you need to be able to help figure out what's what. But if you have something with enol freezing, you write down no reaction. Same thing with chlorate. That would be a reaction with chlorate. All right. Good catch. We I will try to accommodate you. So if you get to the station and there's very clear ones, you gotta find a way to figure out how to get it. It might be one thing that you should do, that we can do. Okay? Maybe you have to come up with that shit you can. Okay? But there's ways to identify that when you say, this is like it. This is kind of like it. It's just a thinking.